up, but sometimes there's an occasion where you may need to figure out because it's a different type shape or it's a compound shape or something like that. If you look in your book on page 182, you can see there's formulas for some common shapes of how to figure out the centroids. You got a rectangle, you've got the base and the depth, so it would you would find it, dividing by 2 each way. You got a circle, which is you would divide the diameter by 2, and you got a triangle, which would be the depth divided by 3, and this for each one of those. Okay. So then you look on the next page. Sometimes you have compound shapes like what I've shown here, and that's the same one as in the book. Compound shape, you must use mathematics, and the statical moment of a plane with respect to its given axis will help you get there. So each of these shapes that make up whatever this figure is, you divide it up into simple shapes like this, and then you choose a reference plane. In this case, we're going to use the top. So my reference plane will be along here. Now then I need to find the centroid of each of these shapes and how far it is from this reference plane. So if you consider each area as a force, their combined moment about the reference plane is how you figure this out. So we have this one, which is 9 square inches. It's a 3 by 3, so you got 9. You got this one, which is 5 inches by 1 inch, so that would be 5. The area of that one is 5. Change my line type. And then you got this one at the bottom that's going to be 8 inches by 1 inch, so that's the area of that is 8. So the centroid in these simple shapes is going to be, half of that distance from there to there. So for this one, if you draw a little dimension line, you've got that centroid is going to be, if that's 3 inches, it's going to be 1.5 inches, right? So this one down here, you know that this is 3 inches and this is 5 inches long, so that centroid is going to be an additional, so that's 2.5. What happened? Damn it. Did I erase it? It's retarded. Okay. That one's going to be your 3 inches plus 2.5 inches, or from there, if you take off the 1.5 plus 2.5 is 4, right? And then finally, you got this one down here, which goes to the middle of that one. So that's going to be 2.5 plus 1/2 is going to be equal to 3. So that's important to know, the areas of these and the distance from your reference plane. They all have to be from the same reference plane. So once you figure that out, you draw your simple diagram, you can do the moment. And so considering that, you can do a combined moment about the reference axis. So the way you do that is, let me just, is you would say, this is 9 square inches. I wrote that there. There. And it's 1.5 inches. So you're going to have, let me write some text. Menu tools. Text. So you're going to have your moment equals your 9 square inches times the distance 1.5 plus the next one, which is going to be 5 square inches times 5.5, and then plus the next one, which is going to be 8 square inches times 5.5, 8.5. So then if you figure all that out, m equals, it's going to equal 109 inches cubed. I don't know how to write cubed, so I'm going to write it like that. And it's, I didn't write the like inches up here, but that's, it ends up being inches cubed. So with that, since the moment of the entire area about the axis may be equated to the product of the entire area, and you add up all of these areas, 9 plus 5 plus 8 is going to be 22, times the single centroid. So you add up all of these moments, and that, then you can figure out what your centroid is. So the area of the whole area is going to be 22. So the whole moment is going to be equal to what you figured up there, 109, which is also going to be equal to the total area times the centroid distance. So you got all this 109, which equals the moment we got before. Another way to get that is the total area times the distance to the centroid, because if you add all of these areas up times the centroid, which is going to be to the reference axis, it equals the same thing. So then you do your math and you say C equals 109 divided by 22, which equals the 4.955. So now you know that if you're trying to figure out where your centroid is, it's going to be somewhere, if this whole distance is 3 and 5 and 6, 3 and 5 is 8, I'm sorry, 3 and 5 is 8 and 1 is 9. So it's not going to be exactly in the middle, it's going to be a little bit above it. So when you find your, and you'll need to know how to find your centroid for other problems later on. So that is going to be equal to 4.955. And then if you wanted to double check yourself, you could go the other way around. You know, put your plane of reference down here and do it all over again and see, and it should come out the same way. Does everybody understand that? Is there any questions? Please let me know now. Does that make sense? Hello? Okay. Okay, so I'm going to keep moving, but your homework for this is going to be doing the problems on the 10.1a and b, and that's written in the Canvas, and that'll be due Tuesday. So you're just going to be, similar situation, you're going to be finding the centroid. Okay? And this will be posted too. So now from that you move on to the moment of inertia. So I wanted to explain that because you need to know how to do the centroid before you get to the moment of inertia. Let me see if I can get this video to work. I thought this was a good common explanation of it.
moment of inertia? Well, you've all seen the formula, it's the mass, distance the mass is from the rotation axis squared. But what is it?